Alright guys, so today we are watching this teacher video to go through day 16 or Tuesday's math work. So this, I would imagine that this day probably took you a little bit longer, a lot of division, and we learned from before that this takes a little bit more time. So when we look at question number 1, the question is, which of the following expressions does not have a remainder of 6? So for me, I would box in not and then underline remainder of 6. And I'm going to have to solve each of these questions. So if I had a separate sheet of paper or an area where I could show my work, then I would set this up just like a partial quotient division problem, 398, and divide by 7. So again, just as a reminder, guys, we want to think, how many times will 7 go into 3? It will not. So then I'm going to think to myself, how many times will 7 go into 39? Well, I know that 5 times 7 is 35. But I can see I still have this remaining place value or this digit, so I'm going to fill it with a 0 and then add my 0 here. Now I subtract, and I have 8 and 4. 48. Well, I know that 7 times 7 is 49, but that's too many. So let's do 7 times 6, which is 42. And when I subtract, I have 6 left over. I can't pull another group of 7, so that means this answer has a remainder of 6. Now, if we remember, the question is, which one does not have a remainder of 6? So I'm going to get rid of that one, and I could even write right here to remind myself it does have a remainder of 6. Now let's look at letter B, 441, and we're going to divide that by 7. Again, does 7 go into 4? Nope. But does 7 go into 44? Yes. I know that 7 times 6 is 42. So 7 times 6 is 42. I still have this place value, so I'm going to fill it with a 0, fill that with a 0. Subtract, 1 minus 0 is 1, 4 minus 2 is 2. Now I want to think to myself, does 7 go into 21? It does, 3 times, and that is 21. When I subtract, I have a remainder of 0. So I could write right here, remainder of 0. Now, which of the following expressions does not? So B is correct. I'm going to check C and D. I don't think this is a select all, but just in case, let's go ahead and write out letter C here, and that would be 3,142 divided by 7. Now again, 7 doesn't go into 3, but it does go into 31. I know that 7 times 4 is 28. Now, I still have actually 2 place values here, so I'm going to fill those with zeros. And now because I added 2 here, I'm going to add 2 right here. Now I can subtract. 2 minus 0 is 2, 4 minus 0 is 4. I can't take 8 away from 1, so I'm going to have to borrow. So this now becomes a 2, this changes to an 11. 11 take away 8, 8, 9, 10, 11, I can count up, 342. Now I need to think, how many times will 7 go into 34? Well, 4 times. I just did that earlier, and that's 28. I still have a place here, so I'm going to fill those with zeros. Subtract. 2 minus 0 is 2. Can't take 8 away from 4, so I'm borrowing again. This is now 14. 8, 9, 10, 11, 12, 13, 14. That leaves me with 62. And now I know that 7 goes into 62 8 times, because 8 times 7 is 56. If I did another group of 7, 7 times 9, that would be 63, and that's too many. So now I can subtract. I'm going to have to do some borrowing. I have 6 remaining, so remainder of 6. So this one had a remainder of 6, so that was not right. Now the last one, D, let's look at this one. I have 4,990, and I'm dividing that as well by 7. So 7 goes into 49, I know 7 times, and that's 49. I still have 2 place values, so I'm going to fill those with zeros, and because I added 2 here, I'm going to add 2 here. When I subtract, 0 minus 0 leaves me with 0, 9 minus 0 is 9. Now how many times will 7 go into 90? I'm not sure, but I know I can take out a group of 10. So let's do 10, and 10 times 7 would be 70. That leaves me with 20 remaining. And now I can look. 7 goes into 20 how many times? Well, let's do 2 groups of 7, which I know is 14. And when I do that subtraction and I regroup, 10 minus 4 leaves me with a remainder of 6. So the only expression that did not have a remainder of 6 was B. Moving right along, let's look at this question number 2. When I read this question the first time, I was a little confused. Maybe you had to read this a couple times as well. Dorothy gets paid $100 for 5 hours of work. The question is, how many hours would she need to work? So how many hours to earn $600? Then they told us here, use the equation 100 divided by 5 is equal to 600 divided by an unknown, and comparative relational thinking to solve. Okay, so this was a little tricky, but there's 2 ways to solve this problem. So when they're talking about this comparative relational thinking, and they're saying, okay, well, 100 divided by 5, I know that that is equal to 20. And I know that because 2 times 5 is 10, and then add on the 0, add on the 0. So what I'm thinking is 20 is equal to 600 divided by what? Well, let's say that you are like me and you're not a huge fan of division. Then maybe you're thinking, what number could I multiply by 20 to equal 600? Well, I know then that m would be equal to 30 because 30 times 20 is 600. Now, some of you, maybe you decided to begin by solving this division problem. And first you were thinking, okay, well, I need to find out how much she makes per hour. So you would have still found that 100 divided by 5 is equal to 20. Then you're thinking to yourself, okay, so if she works a total of 600, or if she needs to earn a total of $600, and I'm going to divide that by 20 because that's how much she earns then per hour, I know that 20 would go into 60 how many times? 3, but then I have that 0 remaining. I would still get the same quotient of 30. So she would have to work a total of 30 hours. Moving right along, question number 3. What is the remainder when 8,638 is divided by 6? So just division. 8,638, and I'm going to divide that by 6. Well, I could take away a group of 6,000 here. I like doing that, making my life a little bit easier. So I took away 1,000 groups of 6 because 1,000 times 6 is 6,000. 8 minus 0 is 8. 3, 6, 2. So I made this number a lot smaller, I think a lot easier to work with. So now I can think to myself, how many times does 6 go into 26? Well, 4, because 6 times 4 is 24, but I still have 2 place values here, so it's actually 400. I can subtract, that leaves me with 8, 3, 2. So now I'm down to 238. Again, how many times will 6 go into now 23? Well, that's 3 times because that's 18. I have a place value, so that's now going to be 30. If I subtract, 8 minus 0 is 8. I can't take away this, so I'm going to have to borrow. So 13 minus 8, 8, 9, 10, 11, 12, 13, that's 5. 6 goes into 58 how many times? 6 times 7 is 42. Let's see, 6 times 8 is 48. 6 times 9 is 54. So 54, when I subtract, I have 4 remaining. Now if we go back, the question wanted to know the remainder. So the remainder is 4. Whew, told you guys this was a lot, but I know you've already done these problems, so you're just kind of following along, checking over your work. How many factors does 24 have? I know I can multiply 1 times 24. I can multiply 2 times 12. Does 3 go into 24? It sure does. And then 4 times 6. So if I count the factors, I have 1, 2, 3, 4, 5, 6, 7, and 8. Don't worry about question number 5. I've never seen a question worded like that, and it doesn't even really make sense, so we're skipping right over it. All right, let's take a look at this problem. They want to know In which of these equations is the value of n equal to 14? So where could you plug in 14 here and make this statement or expression true? Well, first we need to solve the other side of the equation. Now this looks difficult and it looks like a lot of work, but really just use your basic facts. Imagine that these zeros right here are all gone. So 4 times 6 is 24, but add on the 0. 6 times 6 is 36, but add back your 0. 7 times 6 is 42, add the 0. 9 times 6 is 54, add your 0. So now the second part of this, we have to figure out which one could we use to substitute n with the number 14. Well, again, imagine these zeros are gone. So 14 times 3. I can use repeated addition. And I can add these together. 4, 8, 12. Put the 2 here, carry the 1. 1, 2, 3, and 4. So 42, but add back the 0. So where did I get a product of 420? Letter C. Come here, Bren, right now. Let's look at question number 7. We have to use compatible numbers to estimate the quotient of 234 divided by 5. Go sit down right now. I am recording a video for my students, and now they're going to hear this interruption. Go sit down. Excuse me. Bren, then you can sit right there and watch. I need you to be quiet. Thank you. Sorry about that. Use compatible numbers to estimate the quotient 234 divided by 5, then select the exact answer. I don't know about you, but I just changed this to 200 and divided by 5, and I knew that that was equivalent to 40. I know that because 5 times 4 is 20, and then adding on that 0. So those were my compatible numbers that I used. Now to find the exact answer, what we have to do is take 234 and set this up like a division problem, dividing by 5. Well, 5 doesn't go into 2. Does it go into 23? Yes, 4 times. That's 20. Fill in your 0 here. So add it here. Again, that makes sense. 5 times 40 is 200. Subtract, you have 34 remaining. How many times will 5 go into 34? I think 6, because 6 times 5 is 30. We subtract, we have 4 remaining. I can't take away another group of 5. If I add these partial quotients together, that gives me a total of 46 with a remainder of 4. The correct answer was B. I know this is a long video, guys. Stay with me. We've got 3 more. Select all the true statements. So 5 is a factor of 32. I know that's not true. 5 doesn't go into 32. 6 is a multiple of 42. That doesn't even make sense. Multiples of 42 would be like skip counting by 42. If you start at 42 and then you go up, the next one would be what, 84? You're never going to arrive at 6 if you continue. So that doesn't make any sense. 70 is a multiple of 14. Well, I would have to start by adding 14 and 14. That would be 28. So then I could add on another group of 14. That would be 12, carry the 1, 2, 3, 42. Let me add on another group of 14. That would be 6, 56. Let me add on another group of 14. That would be 10, carry the 1, 5, 6, and 7. 70 is a multiple of 14, so that one was correct. 2 factors of 35 are 3 and 5. Well, I know that 3 does not go into 35, so this is false. 20 and 49 have no factors in common. So what you probably did was listed the factors of 20, which you know are 1 times 20, 2 times 10, and 4 times 5. Then maybe you went ahead and listed the factors of 49. 1 times 49. Does 2 go into 49? No. 3? No. 4? No. 5, no. 6, no. 7, yes. 7 times 7. Now, maybe you went ahead and solved for the rest of these, or maybe you thought to yourself, well, does 10 go into 49? No. Does 20 go into 49? No. Okay, so these have no factors in common. So C and E are correct. Next one, question number 9. A bushel of apples weighs 18 kilograms. Henry buys 3 bushels. A cloth bag can hold 2 kilograms. How many bags can Henry fill? Whew, okay, 2-step problem here. First, we need to find out, let's see here, what the total weight is in kilograms of these apples that he buys. So if each bushel weighs 18 kilograms and he bought 3 bushels, let's add 18 3 times. Same as multiplying 18 times 3. So this would be 24. 2 goes here, 4 here, 2, 3, 4, 5. 54. Now, we know that a bag can hold 2 kilograms. So how many bags can he fill? So what we're going to have to do, we need to figure out how many bags he's going to have to buy. So which of these numbers multiplied by 2 will equal 54? Come here. Come here right now. Come here. 54 divided by 2. I can use partial products, or I could take these and simply try to multiply by 2. So 54, I think, how many times does 2 go into 5? Well, 2 times, right? 2 times 2 is 4. That's a 0. Oh yeah, 2 times 20, 40. Subtract 14. How many times does 2 go into 14? 7 times. That's 14. Subtract 0. 20 plus 7 gave me a total of 27 bags. B. Almost there. We've almost made it. Last one. Which statement is true? The only factors of 5 are 5 and 1. Therefore, 5 is prime. Well, if I list factors, yeah, 2 doesn't go into 5, neither does 3, neither does 4. So it is prime. That is true. Let's look at the others. The only factors of 6 are 6 and 1. Well, no, I know that 2 times 3 goes into 6, so that's incorrect. And 6 is not prime. It's composite. The only factors of 12 are 12 and 1. That's not true. 2 times 6, 3 times 4, so that's wrong. The only factors of 37 are 1 and 37, therefore 37 is composite. Well, yes, that's true, 1 times 37, but composite means that you have more than those 2 factors. So the correct answer is A. I know this is a lot today, guys. The division typically takes quite a bit longer. Message me or let me know. We'll talk tomorrow morning if you have any questions on any of these problems. Great job today.